This tutorial covers a variety of developments in SimSmith. The most recent version is now 4.12. Several new capabilities have been added, including an import function and a library function. Minor updates to SimSmith include the introduction of some new components and some usability features, which I hope will make SimSmith a more attractive tool in your toolkit. Probably the most significant usability feature new to SimSmith is the automatic saving and restoring of a session. As of 4.12, SimSmith keeps a file on your disk which contains the most recently edited circuit. If you exit SimSmith and restart it, SimSmith will attempt to restore the circuit to the last edited state. The first time you use SimSmith, you will see a warning that SimSmith cannot restore the previous editing session. Let's see how that might look. As you can see, if there is no previous session, SimSmith pops up this menu, and you click OK, and you can get started. Now let's modify the circuit, end the session, and restart. I build a circuit, change some parameters, and quit. Now, when I restart SimSmith, SimSmith will read in the previous session, and we can start anew. Notice that the name of the previous session is last.simsmithcircuit.s. This file is stored in the working directory where SimSmith was invoked. SimSmith also takes a command line argument. This argument is the name of the startup file. See the primer for details. Let's switch gears now and take a look at the library function. The library allows you to configure a component in your circuit and then save it away in a library. This is particularly useful for function blocks, but can be used for more mundane work. Let's take a quick look. Let's start a new library. Having provided a library file, this library icon pops up down here in the lower left-hand corner. It's intended to look like books on a bookshelf. Now let's add some components to the library. We can put them in our circuit, change the values a little bit. Now we can put them in the library. Notice that when I put something in the library, it's taken from the circuit and put in the library and deleted from the circuit. Originally, I left it in the circuit, but I found myself constantly moving it to the library and then deleting it, so I changed it to work this way. I hope this works for all of you. Now suppose I want to retrieve the components from the library. I can click on the library icon. I get a menu of the items that I've put in there, and I can restore them to my circuit. Notice that when I take a component out of the library, a copy is left in the library. You can remove items from the library simply by moving them to the garbage can. And you can get rid of the library altogether by specifying a file, canceling it, and saying clear the library. SimSmith now allows you to write and import load files and to use them as references in the SWR and Smith charts. Let's take a look at this. Start with a clean slate. Let's add a circuit. A simple pi network is always fun to watch. And if I sweep the frequency, you can see I get this curve, and if I look in the SWR, I get a curve that looks like this. Now, I can take the outputs of this analysis and save them away for further reference, simply by writing, picking a file. You of course can specify a new name. Now I can get rid of this circuit, put in a different circuit, say a T network. And say I want to compare that with my previous circuit. I can read back in, I can import this file and see there was the result of my previous circuit. This is the result of my new circuit. Now I can save this trace, this red trace, as a second reference. Write my touchtone file, specify the file name. Now I can get rid of this. And I can load into that other file that I just wrote. And there's my reference. Now if I put in yet another circuit, here's a simple one, I can have my first reference, my second reference, and my present trace, and I can show the SWR. Notice what happens when I turn to looking at a single frequency. Everything seems to turn away, but if I change, everything seems to disappear. But if I change the operating frequency, you can see the circuit that I'm presently analyzing. Here's the circuit that I'm presently analyzing. And these zeros, or O's, represent the impedance of the references at that operating frequency. So if I do a sweep to look at my whole trace, you'll notice these circles move along the impedance lines of the reference. You can get rid of references simply by clicking on them. SimSmith asks if you like to delete it. You say yes. And of course, if I exit out of here and I restart SimSmith and I turn sweeping back on, here's the circuit. I can get rid of this one. And that's it. As I said in the intro, SimSmith has added support for some new components. Let's take a look at a couple of them. We'll start with the transformer. Earlier versions of SimSmith had a confusing view of transformers because it allowed the user to overspecify the device. To reduce this confusion, SimSmith version 4.12 now supports two different views of transformers. Let's take a look at a simple case. Suppose I want a transformer which is close to ideal and simply transforms one impedance to another. Let's draw it up. Let's start with an impedance that we want to transform 5 into 50 ohms. I put in a transformer. Notice that this transformer model is called the coupled. It is, in fact, two inductors coupled by some value K, in this K1. To do a simple transformation, this model has the advantage of making it straightforward. If I want to transform 5 into 50 ohms, I can set this inductor to be 50, and I can set this inductor to be 5, and I get my impedance transform. Notice that these are in henries. These are very big inductors. They're so big that this transformer is essentially ideal. And if I sweep the frequencies, you'll see that every frequency ends up here at the end. You'll notice, though, that the path that SimSmith draws is very arduous. That's because it's modeling this as a T network of inductors, and there comes a point where the impedance is extremely low. Now, this model is the preferred model of SimSmith, but it can be a little confusing for those unfamiliar with coupled inductors. The other view that SimSmith provides is what's called a simplified view, which I can get by clicking on the model, and you'll notice this is simplified. And here I specify only this inductor, and I specify the turns ratio. In this case, the turns ratio is 0.31. That's because this side is low impedance and this is high impedance. If it were the other way around, the turns ratio would be closer to 3. Notice that in this case, the line taken by SimSmith between the input and the out impedance is a straight line. A quick note here, if you don't know the impedance of the inductors, you can just choose a really high value. Here we use 50 henries, and this is a very big value indeed. SimSmith recently introduced one other significant component called the S block. The S block allows you to read in Touchstone S2P files which specify scattering parameters. Scattering parameters can be used to specify the operation of any two-port device over a range of frequencies. Let's load in a file kindly provided by one of SimSmith's users. I put in an S block to load the file. Here's an S2P file. This is a very, very narrow filter being analyzed here, from only 10.675 to 10.725. If I show it in the SWR, you will see the familiar bandpass filter. One of the nifty features of using S2P files is that other tools generate them too. For example, the latest version of Tone's ELSI can write S2P files. Also, various vector analyzers such as myVNA can write S2P files. You can incorporate these S2P measurements directly within SimSmith to continue our exploration. During this tutorial, I have introduced some recent additions to SimSmith. We saw how SimSmith allows you to stop a session and resume it later. We saw how SimSmith can use a library to hold circuit elements for later use. And we saw how SimSmith can write out and read back reference files. We wrapped things up by looking at two relatively new components, transformers and S blocks. We saw that these two components had different views which can be chosen by clicking on a parameter. I hope this model has provided you with some insight on how to use these features, and I continue to encourage you to contact me with any bugs or any features you might like to see. Thank you.